Hey folks, just a video to introduce the Earthquake Epicenter Lab. This one has a few things that need some comments, I think. So if you're having trouble, watch this video and maybe it'll help. So one thing we're looking at is seismograms. And so if you look here, you can see this is a type of seismogram called a heliograph. It's 24 hours worth of data. You read it just like you would read a page. It goes from left to right, top to bottom. Each line is 1 hour's worth of data. You can see what hour it is over here and what the minutes are across the bottom here, from 0 to 60 and from 0 to 23 on the left-hand side. 24 hours of data, 24 lines of data. And in this one here, you can see there is actually an earthquake, and we are going to try to use those earthquake waves to try to locate the earthquake epicenter in this lab. And the first thing they're asking you is, what hour did the earthquakes arrive during? And here we just want a number, 1, 2, 3, 4, 5, 10, 11, whatever it is, whichever hour the earthquake waves came in during, we want you to write that number down there. And then how many minutes after the hour? So you have to look here and see how many minutes is this after the hour, and do your best estimate on that. And then how many minutes did it take to get back down to background? And you'll notice it goes through that hour and into the next. And then few other questions that I think are self-explanatory here. Now this is a zoomed in version. So what we did is on the JMSI software, we extracted the data and we zoomed in on it. And now we can put the mouse cursor wherever we want, and it will tell you what the exact time is that the earthquake waves arrived. But in this case, I want you to estimate. So from right here, look here, this is 3 hours and 10 minutes. This is 3 hours, 10 minutes, and 30 seconds. This is 3 hours and 11 minutes, 11 minutes, and 30 seconds. So these numbers here are the minutes and seconds. They're not times in hours and minutes. They're in minutes and seconds. They are times. So if we go down here, so we want to know how many seconds is this after 310. This is 310. How many seconds after 310? And in this case, we've zoomed in on the same earthquake, but in this case where the S waves arrived. And in this case, you can read it off right here. So it's 3:18:52. And then we need to calculate how many seconds elapsed between when the P waves began and when the S waves began. And you can do that in a number of different ways. But remember that it's minutes and seconds, not a decimal. And so you can use hours, minutes, and seconds here and here. This is a little bit of code that you can use to do that calculation for you. You put in the start time in hours, minutes, and seconds, or just in minutes and seconds, or hours, or seconds, or whatever. And then hours, minutes, and seconds for the end time. Hit the calculate button, and it will calculate how many seconds that is. And we need to know how many seconds it is, not minutes and seconds, because we're going to use this here travel time curve. Travel time curves take a difference in arrival times, the S wave minus the P wave, and convert that into a distance in degrees along a great circle. And so if it was 600 seconds, we would follow this line over and see that it crosses right at the 80-degree line. So if it was 600 seconds, then it would be about 80 degrees away. So all you have to do is find the number of seconds, go over to this line, down, and read off how many degrees that is. And then there are also some questions where you're going to calculate the magnitude of the quake. And for that, you're going to need a nomogram. And so there is a nomogram in the content area. There's a link to it right here. And it looks like this. So all you do to find the magnitude is find the difference in arrival times, S wave arrival minus P wave arrival, on this axis. So if it was 24 or so, it would be right there. And the height of the wave, or the amplitude of deflection from baseline, basically that wave's height. So it was about 22 or so. It's right there. And you draw a line between them, and where it crosses the middle, you read off what the earthquake's magnitude was. In this case, about a 5.0. And you read it to the nearest tenth. Okay, so you'll do that for several of these. You can print that out, or you can just download it and use some kind of drawing software to draw lines across it. Now you're actually going to locate an earthquake epicenter. And first, I give you 3 different seismic stations: JTMN, MBTX, and LEOR. These are part of the IRIS network. I tell you when the P wave arrived and when the S wave arrived, and then you can use that same travel time curve up here and the same calculator to figure out how many seconds elapsed between the P wave and the S wave, and then use that to convert to distance in degrees. Once you've got the 3 distances, then you're going to draw 3 circles on the Earth to see where they come together. And if they come together at the same place, that is where the epicenter of the earthquake is. And to do that, we've got this here. This is a website from the British Geological Survey, and it has a method of doing that. So it's got a map right up here, and it's got a place for you to choose a network and a station and type in the distance in degrees and draw a circle. So we could choose Iris, and we could choose whatever that is, Aztec High School, and a distance of 44, let's say, and click go, and it draws a circle just like that. Only you're going to pick the stations that are specified in the instructions, and you're going to use the distances that you determine using the travel time curve. And hopefully they're all going to come together, and you should be able to then use your mouse to figure out what the latitude and longitude is, and that's given right over here. It says mouse latitude, mouse longitude. And you're going to do that for that one, for this one here with this data, and then give the latitude and longitude to the nearest degree. Okay, remember, if it's south or west, you have to use a negative sign. But don't put a positive sign in, because D2L doesn't like that. And then another one you're going to do in the content area, there's also a PDF of several seismograms on a printout. And there are, this is in a horizontal scale of 1 centimeter equals 1 meter, 1 minute. And so you can use a ruler to measure the time between the P and the S waves. So rather than giving you the arrival times of the P waves and S waves here, we can just measure the difference in arrival times directly. And then once you've measured it in minutes, you can convert to seconds, multiplying by 60, and use the travel time curve again to determine the distance to those to the epicenters. And use the BGS earthquake locator tool to draw the circles, and that should be good. Answers in latitude and longitude there. All right, any questions? Shoot me an email.